All right, good morning, everybody. My name is Mark Shuttleworth, CEO of Canonical. And this morning's presentation is a joint presentation, so two segments. I'll do the first segment, and I'm delighted to be joined for the second segment by Kandan Katravel, who's a Director of Cloud Strategy and Architecture at AT&T. And so you're going to hear two perspectives on OpenStack, one focused on the enterprise, essentially things to think about and approaches to take for success when you're building an OpenStack in an enterprise context, a private cloud. And then one which is almost the opposite end of the spectrum, which is when you're building possibly what might end up being the world's largest OpenStack and the world's most distributed OpenStack. So OpenStack as a primitive for distributed computing at enormous scale. Kandan, thank you very much for joining us, and we look forward to your segment a little bit later. So OpenStack is complex and fast-moving, and there are lots of components to it. As a result, there are a million different places you could start or things you could get drawn into or pieces that are interesting and choices to make. The short version of what I'm going to say about OpenStack for the enterprise is this. Remember, you will be judged, your private OpenStack will be judged by the business as a whole, and it will be judged against pretty simplistic metrics. There's a ton of interesting complexity and technology available to you, but in the end, businesses tend to take the view that they either want to be directing more VMs onto your private cloud that you're building, or onto another alternative. It could be VMware, or it could be the public cloud. And so the two fundamental tests, effectively, of fitness for your private enterprise cloud are going to be these. First, the cost per VM. And it's a horrible thing for a technologist to have to be reminded of, because we far prefer getting into what's possible. But at the end of the day, your infrastructure has to compete with both VMware and the public cloud. And it's a very bad position to be in, to have to be explaining why your infrastructure is more expensive per VM effectively than VMware, which is understood by the business, whatever else they may think about it, or the public cloud, which is increasingly seen as a viable commodity market for compute and other services. The second big gate that you have to get through is really the health gate. It's not enough to stand up OpenStack once. You have to think about keeping it healthy, which means daily operations and things like upgrades. The vast majority of if you think of a 6-month period, there's the work that you could do to make OpenStack better, and then there's the work that the entire OpenStack community does to make OpenStack better. It is far better to be optimizing your efforts to be able to get access to the newest version of OpenStack every 6 months than it is to be adding a particular feature here or capability there. And those two things go together, really, because ultimately the biggest overhead associated with the economics of OpenStack is consulting and so on. So a mistake that we see a lot of clouds make is that they think that upfront their cloud is going to need to be different, and so they need to bring into the house a lot of skills, either as direct hires or as consulting, in order to essentially make a unique OpenStack. And what you need to think through is, what's that going to do in 6 months' time or in a year's time when you're getting evaluated? If you've spent $1 million on consulting and you only have 1,000 VMs, that's $1,000 per VM effectively of overhead, which is very, very high compared to what the business would see on a public cloud or in VMware. And so that potentially leads you down a slightly different course in terms of the way you think about your strategy for that private cloud. You also have things to think about, like depreciation and hosting costs, the integration costs to existing back-end infrastructure services in your enterprise environment, automation costs and ops headcount. All of those come together. So the first sort of strong learning that we take away is that almost certainly you want to start with reference architectures and minimize the amount of consulting. Now, I'd caveat that. I'd say if you know up front that you are going to be 4,000 nodes within 2 years, then it makes sense to essentially run a parallel track of consulting and architecture work. But you almost certainly want to be doing that in parallel with reference architectures, which are essentially getting developer engagement while at the same time you're building that kind of custom architecture, and I'll talk about that a little bit later. The second piece is, when you're building a private cloud, you're trying to shift economics in favor of CapEx. OpEx is great, and people say that they love OpEx on the cloud, but most businesses have a way to think about when they buy stuff and when they rent stuff. They do both of those things for most asset classes. When you're buying stuff, you want to be shaping that so that you're getting the most efficient use of capital. And there's a bunch of stuff you can think about there. The easiest way for us to sort of help you with this is we can give you essentially a reference bill of materials from each of the major manufacturers. If you like Dell, then this is the SKU to get right now that offers the best bang to the buck. If you like Supermicro, HP, Quanta, these are essentially the SKUs to get that would line you up with what the public cloud guys are doing and would get you the right economics for compute effectively and storage. Obviously, the pricing that you get is a function of your relationship with those institutions, but you want to really avoid the sales process that would lead you down to getting this kind of hardware for this function and that kind of hardware for that function. You really want to be essentially consuming compute and storage as a commodity. There are some architectural things that go with that. For example, hierarchical storage acceleration using NVMe or Optane, for example, the newer stuff from Intel, as an accelerator in front of slower, cheaper per terabyte storage. If you go inside a Google data center, you will see a lot of rotating disks, right? It is just the cheapest way to have petabytes and petabytes and petabytes of storage. But obviously, you want to create a different performance dynamic around that. So things like Bcache for hierarchical storage acceleration make a big difference there. You also really want to understand how the big guys are building their networks. It doesn't look like anything like your traditional enterprise network. So you want to be tapping into the market for white box switches. The price of 100 gig E, for example, 50 gig E is plummeting because that's what the big guys are buying. And if you can figure out how to ride that wave, you will see much more efficient economics around your network. And then you very much want to be able to show that every single piece of compute asset that you have is working. In other words, you don't want to be segregating your cloud infrastructure into a control plane piece and a storage piece and a compute piece. You want to show that everything is adding value to that whole story, and containerization of the control plane is the best way to do that. Okay, down at the bare metal level, what we found works best is simplicity, right? So metal as a service is used in thousands of different institutions to operate the data center. Essentially, we'll give you on demand a machine with Windows or CentOS or Ubuntu. It's used, for example, at Microsoft to do beta testing of Windows. They'll just blat today's build of Windows onto hundreds of servers and then test it. It's used in Salesforce to deploy mostly Windows and CentOS. It's used in a bunch of gaming companies. The biggest users of MAS are actually companies that you would think of as tenants on public clouds, right? Brands that you think of as customers of the public clouds. But those brands are now figuring out that at scale, it pays them to be able to operate some private data center capabilities as well. And they want a cloud experience, on-demand compute effectively for that physical compute. They want it as simple as possible, and they essentially they choose MAS to do that. I have MAS running on this box. This is sort of a half-rack demonstration unit. There are 11 Intel microservers in here. One of them is running MAS, and then it lets me essentially commission, test the hardware, deploy Windows or CentOS or Ubuntu on anything. I can do that all programmatically effectively. To show that in action, this is that MAS dashboard. So you can see some of the machines are switched on, some are switched off. The ones that are switched on are actually running an OpenStack. This is the Horizon dashboard for that OpenStack. I may need to log in again. That was built effectively with a single command using a model-driven approach that gives us sort of easy access to reference architectures. If I just check where I am, this is that OpenStack model. So you can see a bunch of the familiar applications of OpenStack, Ceph, Cinder, Glance, Nova, OpenStack Dashboard, which is Horizon, RabbitMQ, and so on. And then if I sort of scroll down, you can see how that's mapped to the machines and containers effectively for a containerized control plane. And so that's a model that's easily accessible. I'll talk a little bit later about model-driven operations, but what you really want is the cheapest and easiest way to stand up a standard OpenStack so that you can get developer engagement, and this is certainly the reference approach as far as we're concerned for doing that. Coming back to this story over here, if I wanted to build Kubernetes, for example, on bare metal, using MAS. You can see there's a bunch of lights there that are switched off. I can do that by switching to a clean model and then just deploying, again, a reference Kubernetes. And so what this is going to do is pull in from the cloud standardized operating code. So essentially think of it as standardized Chef or Puppet encapsulated so that lots of people can reuse it. This same model of Kubernetes will work on a public cloud or on bare metal. And what you'll see is as soon as the model has been loaded, it will talk to MAS. It will go and fetch the machines that it needs to operate that Kubernetes. You'll see lights coming on. Essentially what's happening is MAS is going to pick some machines that fit the model, install the right operating system, and then install the applications effectively that will spin up that Kubernetes. So if I switch to the node view of that MAS, shortly you will see some of these machines switch to deploying. The operating system will get deployed, and then once the operating system is deployed, you'll see spinning disks or flashing lights, which are the Kubernetes model being built. So there it comes up. Now I can switch to an identical orchestration controller running on OpenStack. And just see right, there's nothing in that model effectively. I can deploy Kubernetes here. And I'm gonna use a slightly different model just because I'm on OpenStack. I've got VMs, so I don't have to be quite as focused on exactly how I use resources. So I'm just going to use a slightly bigger model and create a slightly more expansive Kubernetes. So I'll come back here. So I'm essentially using exactly the same methodology to work with bare metal using MAS as I am to work with VMs on a public or private infrastructure. And that's really important because the real gates that you have, one is an economic gate. Your time and money are your enemies. If it costs too much to stand up your cloud infrastructure, then the business starts to take a negative view of that cloud and won't grow it. If it takes too long, then your issue is developers have gone somewhere else. They've started to lock themselves into other cloud infrastructures, and it's difficult to get them back. It's difficult to get them onto your cloud infrastructure and grow the amount of utilization of your cloud. In terms of getting it right, I really would encourage you to limit scope. Going faster and being more accurate is easier if you've limited the scope. The two things that I'd say you have to get right, one is infrastructure on demand, so VMs, networks, and disks on demand. The other is Kubernetes. Kubernetes has emerged as a very useful multi-cloud abstraction layer. In other words, you can encourage your developers to build apps on Kubernetes, and then you know that if they do that in a nice, clean way, they'll be able to put those apps onto both a public cloud or VMware or your OpenStack or bare metal. And that's really important because it means that you don't have upfront to convince them to use your OpenStack, but you know that the way that you can steer the way they're building applications so that those applications will be able to come to your OpenStack as soon as you can make the case for the economics of your infrastructure. So that's why I'm showing Kubernetes and the deployment of Kubernetes. Let's just see how that's going. Here, essentially, I think those are, so those are on OpenStack. You can see those VMs are being allocated. If I go to the Horizon dashboard and refresh that, here you see those VMs coming effectively to build out that Kubernetes. If I go to, do we have anything happening over there? If I go to the Maz dashboard now, you see a bunch of machines in a deploying state. So again, that's exactly the same model-driven operation system to build Kubernetes on bare metal. I'm just pulling out the machines essentially from a different physical cloud. And if we watch this, you'd actually see all the pieces of Kubernetes coming together. Just for fun, I think I'm going to go and scale that out. So I'm just going to essentially say I don't want 2 VMs providing the Kubernetes worker service, which is what actually runs your Docker processes, your applications. I'm going to add another one, so I'll have 3 over there. And then if we go back to Horizon, you'll see just now another VM will get spawned. And that's where that piece of Kubernetes is going to go. Okay. So how to think about headcount and architecture. If you're going to be less than 200 nodes in the sort of coming 2 years, the economics of a managed service are going to beat any sort of internally developed ops framework for OpenStack. And that's a very difficult thing for sort of IT to accept, but at the end of the day, over many, many OpenStack projects, that's what we've observed. People who do this repeatedly can just do it much more cost effectively than people who are doing it for the first time. And remember, your goal is to establish that you can deliver VMs for a lower cost internally than VMware, and for CapEx that matches whatever OpEx people would get on a public cloud. While it's tempting to get drawn into all of the technology choices that you can make if you were doing this yourself, you're also adding a lot of risk if you essentially choose to go and make all of those technology choices. And the single most important thing is to show that you can stand up a cloud with good economics that attracts developers. So below 200 nodes, frankly, you should look at a managed service. Something like Bootstack is going to cost you less with all the management included than VMware. Typically, most businesses estimate that VMware is costing them $5,000 per physical node per year. A managed OpenStack service like Bootstack from Canonical is going to cost you less than that per physical host per year, up to sort of 200 nodes. Up to about 4,000 nodes, you want to switch modes and start thinking about operating a reference architecture yourself. Why a reference architecture? Again, you want to benefit from all the work that other people are doing to standardize operations, but you want to essentially provide the headcount for the operations yourself. Up to about 4,000 nodes, that is your optimal mode. And there's room there for some consulting, but remember, all the consulting builds get divided by a number of VMs, and if that drives your cost per VM way outside of the parameter for a public cloud, then it gets harder to attract VMs. Over about 4,000 nodes, you want to be investing in headcount to build your own custom architecture and ops frameworks. Do think about running parallel tracks, right? At the same time, you want to be engaging with developers before you have your custom architecture and custom operations framework and so on. Even if you plan to be huge, you have to engage with your developers because you want to effectively have them participating in that journey with you and shaping the outcome. Because if they've gone somewhere else and locked themselves into APIs on another cloud that you won't be able to provide, it's almost impossible to get them back. Not going to spend too much time on this. This is really just the benefits of model-driven operations. Model-driven operations are really thinking about encapsulating operations code for reuse. We use Juju to do that. It essentially means that every single person who's deploying Cinder or etcd or Ceph is sharing the code to do backups, sharing the code to integrate with a particular monitoring system, sharing the code to handle an upgrade. It means effectively that a ton of work is done for you for free, and you don't have to essentially merge your changes or fork that code to use it. It's a much more efficient way to essentially build clouds cost effectively than creating your own ops code. Net, you end up in this sort of world. You end up with people essentially operating physical infrastructure at scale with stuff like Maz. Ubuntu is a common platform for both Kubernetes and OpenStack. The Google Kubernetes SaaS is on Ubuntu, so using Ubuntu on-prem allows you to build applications that you can be certain will run on the Google SaaS. The Microsoft Azure Kubernetes is also on Ubuntu. So the Azure Container Service Kubernetes is also on Ubuntu. So using Ubuntu for Kubernetes is a sort of standard primitive for people because it means that their apps will move to those public clouds if they want them to without any change in the underlying binaries or kernels. Our Kubernetes also uses the upstream binaries for Kubernetes, so the APIs are all exactly the same. But you should think of Kubernetes as something that you deploy in a team for an application. Kubernetes is much more like a message bus for an application than it is a cloud or an infrastructure for many applications. And I'm happy to get into the sort of drivers for that particular experience. At this stage, though, I'd like to invite Kandan up to speak. Now, Kandan is a strategist at AT&T, so he's looking forward at future architectures, but also has been very involved in the existing Domain 2.0 architecture and the evolution of that. So Kandan, please join us on stage.
Thank you. So I want to talk about what is really needed in order to be successful with the edge cloud. And we've been using OpenStack in the centralized cloud deployment for a while, and especially the telcos, we are using OpenStack for orchestration of the network function virtualization, which is taking all the physical routers and switches, what we typically call as a physical network function, and converting them into a virtualized workload. And that has been happening for the last couple of years, and that's where the centralized clouds are being deployed. So the million-dollar question that's everybody asks right now is that, how do we use OpenStack to support edge cloud? The other question also comes up is like, do we really need OpenStack to support edge cloud, right? Can everything be containerized, and can we use containers to run everything in the edge cloud? So in this picture, you guys can see that in terms of the scale of the edge cloud versus centralized cloud, it is really a difference of numbers like really huge. So if you look at centralized cloud, we're really talking about tens to hundreds of locations. But if you talk about the edge cloud, we're really talking about thousands of locations or millions of locations, depending upon where this specific edge cloud is going to be deployed. So the question is actually, in order to deploy OpenStack or the whole cloud stack into a data center which are 10 plus location or 100 location, itself is very complex. But when we talk about deploying this actually in hundreds of location or thousands of location, then the complexity really goes up really a lot. So then in this case, like, how do we manage it? And what are the approaches that we can actually take in order to support it? So to fundamentally answer the question, do we really need OpenStack to support edge cloud? In my opinion, the answer is yes. And the reason is that if you look at this picture, on the left-hand side of this picture, the customer devices, AR, VR end user, all this edge application, okay? So there are typically application, these can actually run in a container mode. For example, if you really develop a new application, it's really better to start with the container workload, especially as a microservices. So you have a flexibility of creating quicker. Operationally, it's easier to maintain. Then why do we need OpenStack? Can we use Kubernetes to completely orchestrate everything? I think the answer is really on the workloads that we cannot really make it as a container, at least for next couple of years. I think over a period of time, this technology shift will happen. So if you take the virtual network function that I talked about, and not every virtual network function is ready to convert themselves into a container-based microservices workload right now. And for example, we take we talked about on the yesterday talk, virtualized RAN, and the 5G infrastructure itself is actually getting converted into the cloud deployment. So in this case, if you look at it, the workloads are actually getting converted, but they're not ready to completely support container because of the stateful nature of the VNF, and they also need higher performance. There are security requirements that doesn't allow us to completely deploy as a container. So in this case, so there are certain type of workload which is not ready yet to be purely a container, or it doesn't make sense to actually deploy as a container. And there is a workload that you can deploy as a container. So this is the distinction that especially for the workloads that we really need to orchestrate for a VM, and OpenStack definitely make a sense, right? So I think that's where the answer is. We do really need OpenStack in terms of supporting the edge cloud. So the question really comes down to is like now we understand that we need to support VM and also we have to support container. So the question really is that, what do we really need to do in the OpenStack to support edge cloud in this massive scale and stuff like that? So if you look at this architecture, so this is sort of a reference architecture of edge optimized stack. And in this case, we have a combination of, open sources. So if you look at the bottom of the picture, we have a compute, different type of compute like CPU, GPU, and all the stuff. And then we have a storage network. Then we also have the hypervisor, and we also have the orchestration that actually manage the hypervisor in terms of creating a container or in terms of creating a VM. So this is where the OpenStack Kubernetes really comes into a picture, along with software-defined storage, something like a Ceph. Then in the top, we do really need something which actually can orchestrate the container, orchestrate the VM in a large-scale deployment model, especially in a telco world. We really need something to actually orchestrate this virtual network function. So ONAP is a community which actually provides a very nice way of orchestrating the virtual network function along with the containers too. So the combination of OpenStack and ONAP, that is what it's currently, AT&T in our example, we deploy this and many other providers are deploying in their data center and managing the VNF in the data center world. We can take this same architecture and use that for the edge, but we do really need to adjust a few things, and that's where this requirements comes in. Like edge brings up the additional requirement we talked about, like scale and the complexity involved. So the design, build, and operate has to be very simple. And if it is not simple, then it is very hard to manage that 10,000 plus location or even a millions of location. So how do we make it very simple? So the simplicity really comes from a finite set of configuration, because in the data center, what happens is that the requirements comes from several angles, right? It comes from the NFV workloads, it comes from the enterprise workloads. We're trying to do a lot of stuff in the data center based workload. That's what the OpenStack, we look at it, we have core projects, then we have other projects around it. So it is a lot of requirements we are trying to address into a one software module, and we are trying to manage that, So in this case, like in the edge compute, we probably don't need that many use cases need to be addressed, because it's very prescriptive use cases of, I need workload, and this is the characteristics of the workload. And if we agree on that, then the complexity of the orchestration layer doesn't need to be, too hard, like as a data center. So that's what I call that as a finite set of configuration. Then wherever it is possible, we can actually run cloud native application. And this is where we want OpenStack also to run as a container, because typically the deployments, so far most of the people who are actually using OpenStack deployment as the VM. And before that, it was a bare metal. The technology is shifting towards like running the OpenStack in the container. And we've been pushing on the OpenStack Helm project, which is basically, like running the OpenStack in the container. So in this context, what I look at it is like two aspects to take away from this particular slide. The number one is like, there is not a huge difference from architecture perspective from edge versus data center. But there are additional requirements with respect to edge. That's something we need to address. And the second part is that it's really about that, the tooling set we would use to install the whole stack, either it is in the data center or in the edge. Because we don't want to end up on a situation that allows us actually that I have to manage a data center in one way, and then edge in another way, then that allows like a complexity, more complexity, and it's a lot of cost of investment need to be done to maintain like two type of tool set and a different operational model. So we really need a one sort of like a tool set to manage both edge and the data center. But the key is actually the zero-touch provisioning and zero-touch operation. This is needed either it is an edge or in the data center. So that's where like our thought processes here is that we really need an end-to-end solution in the community itself that actually can be contributed into it. So if we take OpenStack, we got OpenStack, then we have SDN solution and other open source. Then we have ONAP, then we have like a lot of things comes out of Linux Foundation. So we have combination of things across like a lot of open source. Then the integration part became very, very complex. And if the integration part became very complex, then everybody, even though it is an open source, but every provider or user ends up on a different configuration. So there is not really a full-fledged open source end-to-end solution. That need to be addressed in the community. If we address that in the community, then the requirements what we saw on the previous slide, it is easy to address that. So if you look at this picture, so we got a host OS, then we got a Docker, Kubernetes, and Helm to support the container workload, then run the OpenStack about that to really support the containerized OpenStack. But we also are developing a set of tool that we're willing to contribute back into the community. And this is purely an upstream open source project that we have created. Is like something like Promenade, Shipyard, Dry Dock, Armada, Deccan. These automation stack is to really can install either it is an edge or in a data center. If it is edge, as we said, like it has to be a small scale deployment compared to in the data center, it has to be a large scale deployment. The other aspect is that like really the end-to-end orchestration we talked about. That's a top layer of the ONAP. So this is our approach. So our view from AT&T is that we like to see an end-to-end stack in the community. And this is the same voice that every user is actually reflecting, is that we really need an end-to-end stack in the community so that the community can collaborate and build this edge stack. So I think many of you have attended this Open Dev conference, and it happened in San Francisco on September 7 and 8. This conference focused completely on the edge computing, and it was organized by the OpenStack Foundation. So it kickstarted the discussion about the edge computing in the OpenStack community, as well as the other community what we talked about, because in order to support the end-to-end stack, you really need to have all the community coming together, because it is not just about the OpenStack, because you still have a Kubernetes, you have other modules coming up. So this context of like coming together and all the open source community, whichever needed to build this edge stack, and really support this end-to-end edge stack in the community is very, very critical in order to really make this edge computing happen. Okay, what exactly we need to address in the OpenStack itself? I think the very key point is that it has to be a slimmer, thinner, lightweight OpenStack. The reason is that when I deploy an OpenStack in a large data center, I have a flexibility of deploying it in 5 to 10 locations. But when I'm trying to deploy this in an edge computing, I really have to deploy this in a 1 server or a 2 server model, or even actually in a remote management of it, because I don't have that much real estate to deploy this in a large scale deployment at the edge. So the OpenStack has to be very thinner and lighter. Today, we can actually run the OpenStack in the container as a very, very thin engine, but it still has 10 million lines of code. So the question really comes to it is like the prescriptive use cases that we need to address in the edge. We need to limit that to that use case. So that's where the modularity comes in. Is like if it is modular, then you take the pieces that you really need to deploy in the edge. The additional pieces, whatever else needed to support in the data center would be, can be added to for the data center deployment. So the key is that community should come together and build this slimmer, thinner, lightweight OpenStack. So definitely there is a lot of discussion in the community right now, and I encourage everyone to join that particular discussion. And there are talks from different Different people are doing the talks in the community right now, and we should collaborate together to build this slimmer, thinner, lightweight OpenStack in support of the edge. The second part that really comes down to is like a fully integrated solution. That is very important, being in the community itself, so that like everybody can collaborate and achieve this edge computing as a goal. Thank you.
Thank you very much.
Thank you.
So here you have two perspectives on operating OpenStack. One focused on pretty extraordinary scale and complexity. The other focused on what you would use or what you might think about if you're building an OpenStack for a private institution. But there's a lot in common, essentially, between our architectures, that idea of zero-touch provisioning and automation at the bare metal level. We work very closely with AT&T on that. The use of Ubuntu, Kubernetes, and OpenStack, those are your sort of common operating primitives. Does anybody have questions for Candan and I? It's super interesting to hear what folks are struggling with. Who here is in the, either in the late stages or in the early stages of an OpenStack build-out, or who here differs with the perspectives that we've shared? Does that all make sense? Any questions?
All right, thank you.
Always nervous when there are no questions. We need to blow some more air into the room. All right, let's wrap up there. Thank you very much for coming.
Thank you.